All right, we come now to question 9, which gives us two limits, both of which we are asked to evaluate using L'Hopital's rule. And so the first thing we always have to make sure with a L'Hopital's rule question is that the given limit actually satisfies the requirements of L'Hopital's rule, namely that it must be either a 0 over 0 or an infinity over infinity indeterminate form. If it's not one of those two cases, then we've got some work to do to put it into one of those two forms. So for part A, we've got the limit as x goes to 0 of e to the x minus 1 divided by x squared minus x plus sine x. And so by direct substitution, we've got e to the 0 minus 1, that's 1 minus 1, which is 0 on top, and 0 minus 0 plus the sine of 0, which is 0 on the bottom. So yes, that is a 0 over 0 form, and therefore we can use L'Hopital's rule. So that tells us that we're going to create a new limit by taking the derivative of the numerator and dividing it by the derivative of the denominator. And it's always worth reminding ourselves that that's not the quotient rule. It's not the derivative of the original function. It's a new function created by assembling the derivatives of the two parts of this fraction in this manner. So that means we're working with the limit as x goes to 0 of, let's see, the derivative on top here. The derivative of e to the x is e to the x. The derivative of x itself is just 1. And the derivative of 1, being a constant term, of course, is 0. So that leaves us with e to the x minus 1 on top. And in the denominator, the derivative of x squared is 2 times x, minus, again, the derivative of x, which is 1, plus the derivative of sine x, which is cosine x. And now that we've used L'Hopital's rule, we'll try direct substitution again. And so this time we'll get e to the 0 minus 1, which is 1 minus 1, which is still 0 on top. 2 times 0, which is 0, minus 1, plus the cosine of 0, which is 1, minus 1 plus 1 is 0 again. So we've got another 0 over 0 form. But that's okay, because sometimes we need to use L'Hopital's rule more than once in order to be able to evaluate a limit. And so because we've gotten a 0 over 0 form, it means L'Hopital's rule applies to this limit every bit as much as it did our original limit. So in other words, that's going to be equal to the limit as x goes to 0 of the derivative of e to the x minus 1 divided by the derivative of 2x minus 1 plus cosine x. So again, we've got a couple of derivatives to work out here. So that'll give us the limit of, well, again, the derivative of e to the x is e to the x, and the derivative of minus 1 is just 0, so that just leaves an e to the x in the numerator. And then in the denominator, the derivative of 2x is 2, minus the derivative of 1, which is 0, plus the derivative of cosine x, which is now minus sine x. And so what does direct substitution give us this time? Well, on top now we just get e to the 0, so we just get 1. So definitely not an indeterminate form. In the denominator, we get 2 minus sine of 0, which is 2 minus 0, which is 2. So there we go. That tells us that the limit is equal to 1/2. We'll do part B in the next video.